Okay, hello students. Good evening, everyone. So here we are discussing the live session for the week three content. So in this session, we will discuss some problems related to the uh, free vibration and the force vibration actually for the damped and as well as the undamped system. So in this session also we will discuss nearly around 8 problems. So in this initially 3 or 4 problems are maybe related to will be related to the objective type kind of problems. So that will be help you to like think about your concepts. If your concepts are good, then by looking the problem you can give the answer. And then we have the 4 long problems in which the two problems are related to the unbalanced mass and one problem is related to the finding steady state amplitude, and the another problem is related to some finding out the steady state amplitude for the rubber isolator or something else. Okay, so am I audible?
Yes, you are audible, sir.
Okay, so let's start with the one by one. Like, let me share my screens. Is my screen is visible?
Yeah, visible. Yes.
Why it is not coming to the? Okay, so in this week three content, our first question is that we have a undamped system. Okay, so in the undamped system, we have the response like for a system with the undamped system, and we are applying a force, says force vibration kind of thing. So if we are applying a system with the force vibration, what are the components in the solution we have? Anyone can tell me? Like let us say
I didn't understand. What are the components means?
like in the solution like we have the mu double dot plus kx is equal to pt. So what are the
Okay.
solution part? Like one is the complementary solution, one is the particular solution kind of thing.
Okay. Yes, yes.
So our total solution u total will be complementary solution plus
Plus particular solution.
particular solution. So in terms of
Yes.
the dynamics, we call the complementary solution, we called it as a transient response.
Yes.
Transient response.
Where PT equal to 0.
Yes, for the transient response, this is only due to the initial condition like free vibration only. And
Yeah.
the UPT particular solution is known as the steady state response. Steady state response. And where UT is called as a total response. So let us suppose I have a equation kind of this system like the mm, spring mass because that is an undamped system. So
Sine wave.
So can you tell me by looking the curves, which curve represents the transient response, steady state response, and the total response from all three curves? Anyone can tell me, like curve A represent which response, for B which response, and C for which response?
Curve is addition of B and C, it looks.
Okay,
So it should be total response, very clear.
okay. So you are saying A is your total response.
Yeah. Between B and C, what happens, both are like steady state only. It looks like steady state. Maybe C is looking, I don't know. Here also there is no, I am not able to see any decrement and a logarithmic decrement kind of thing. So between B and C,
Because
it depends
here
on the omega.
because you are not able to see the B decrement because this is an undamped system, so
Yeah,
there
yeah,
would
correct,
not
correct.
be
Yeah,
any decrement. So from B
yeah.
and C you need to find out which one is for the uh, transient and which one is for the steady state.
That will depend on omega and omega n.
Okay, so in the
So unless we know the omega, omega n, T, Tn, we cannot identify which is.
so in the question itself, if you go through the question, we have given a
Yeah.
statement like
Forcing frequency is
forcing
less than
frequency is smaller than the natural frequency, means your omega is less than
natural
omega
omega
n.
is greater. That means
Your forcing,
Tn will be
so your T would be greater than Tn. Is it right?
Yeah.
So
Yes,
T
correct.
T is for the force. This one is the force vibration, and this is for the like the free vibration we can say, or the transient response, free vibration. So here, if T is greater than, so which curve has the T is more time
B
frame?
B is having T more.
Yeah. So if we look at into the B, so the T is for the B is this one. Okay, and for the this one is T for the C. So this one is
No, I
small.
think the B you have to extend still further. The T you have to extend still further. It is passing at 0, 90, 180, 270. You are passing at 270 degrees.
Yeah, that
It
would
should go
be.
to 360
Yeah,
now.
yeah, yeah. Okay, sorry.
Yes, this will be
Yeah, you can take
T.
it from
T for
here to peak, kind of things.
yeah, peak to peak. That is CC actually. Yeah, okay.
So if you will look at into this, like your curve B represent for the force vibration because this T is greater than this T. Let us suppose this is a TB, if we call it TB, and if this we call TC. Okay, so your
Okay.
TB is greater than TC, means your TB or for the force vibration, and your TC is for free vibration. So here your curve A, so we can state like your curve A is represent the total response, your curve B represents the steady state, and your curve C represents the transient response. So this is same kind of problems you have given in the week 3 quiz. So in that question you have the damped system. Okay, just like keep in the mind. So here we solve this problem for the undamped system. There the question for the damped system. So looking at that question, you can find out which one is the for the transient, which one is for the steady state, and the total response. Okay. Any doubt? Anyone?
Clear, sir. Clear, sir.
Okay. So now we are moving some like the another objective type of questions, in which question we have a single degree of freedom system which frequency is natural frequency is given as a 1 hertz. Okay, and that system is excited by p naught sine 2 pi ft. Okay, and where the forcing frequency is the 1.5 hertz. Okay, so which options is correct about the STO, like the damped STO system, like with showing by using this curve? So can you tell me which options are correct, by like the response will decrease by increasing the damping, or response will increase by increasing the damping, or the response will decrease if excitation frequency is increased beyond 1.5, or the response will remain constant with the increase in damping? Anyone?
Response will decrease actually. If the forcing frequency is higher,
Okay,
the response will decrease. Dynamic response will decrease.
okay. Forcing frequency is higher, then the dynamic response is decrease. How you can say?
Yes.
Like if my omega by omega n, like my omega n
Yes.
is like a constant, and if my omega is increasing and my omega by omega n
Ah,
ratio.
1 minute. Actually, what happened? No, see this 1.5 by 1. No, then what happens? It is see just above the root 2. So above root 2 mean about the RMS of the value. So it is still on the. I think it is still on the left side only. Of the peak. If it is still on the left side of the peak, then it will be higher only.
Yes, if your omega by omega n is lesser than 1, then it would be like increasing in the left side, and if it is higher, omega by omega n is greater than 1, then your response will start decreasing. So here we have given like natural frequency fn as a 1 hertz, and f is a 1.5. So my
Okay.
omega n is the 2 pi f, so which is we can I can write 2 pi, and omega is 2 pi f, forcing frequency is a 1.5. So my omega by omega n, if I will calculate, so that will be 2 pi
Minus
1.5.
7 2 root 2 to 1. Yeah, right side. It goes on the right side actually.
So
Yes.
that
So
omega
it
by,
will it will decrease.
yes, so that my omega by omega n is 1.5. Okay,
Yeah.
so which is we call sometimes this ratio we call it as a r. So in
Yes.
the right side, by one, like the when the omega is increasing, omega by omega and increasing, or the omega increasing, so my response will decreasing. So one is option is correct here with the a, like the response will decrease by increasing. Oh sorry, this one c. Okay, so that is the one option c. Now in the right side also, if I increase the damping, my response will automatically decrease, as we can see. So from point 1 to point 5, if we go, we can look at there, like with increasing the damping, my response will always be lesser. So there's option B will not be there, and option C is obviously it is not a proper. So option A and option C are correct. Okay, am I audible?
Yes, sir.
Yes, sir.
So these are two options are okay. So option A and option C are correct. Okay, is there any doubt in this question? Anyone?
No, sir.
Okay, if not, then we are moving to the next question. So in this question also, we need to find out the steady state response of an undamped STF system when it excited by a force P sine omega t, where omega is equal to omega n, means the resonating condition, and where we are assuming the zero initial conditions. If we are assuming like if initial conditions are zero, means our transient response will be. Anyone? If my initial conditions are 0, what would be my transient response? Anyone? Anyone? Am I audible? Na?
Zero.
Yes. If like my transient response is what? Ut is equal to u naught cos omega t plus u dot know by omega n sin omega n t. So if my initial condition u naught and u dot naught is 0, then my ut would be 0. So my transient response will be 0. Now I need to focus only my system steady state response, which is we call as a particular solution also. So for the undamped system like mu double dot plus ku is equal to p sine omega t. Okay, so for this system,
Sir, I have before you go to the next step, I have a doubt here actually.
yes.
U naught and U dot not both are zero. Okay.
So
Yeah,
then your
then
transient
both will
response
be
would
zero.
be 0 because here we in the question initially state that initial conditions are 0. Okay,
Okay, but will this ever happen actually? Like then the phase angle will be flat actually.
with the
Practicality in practicality, we cannot have such a situation
such
like where
situation,
U dot U.
but actually in the force
Yeah.
vibration, what happens? Our transient response will diminish. It's like it will, like our steady state response is more important than the transient response because it is a for shorter
Okay.
time.
Correct. Yeah. Yes.
Okay,
Yes. Okay.
so that's why we also can like we are neglecting this.
Mm.
You can say this
Okay,
system.
but sir, is it practical? Like we can have a situation where U zero and U dot zero both are zero.
No, it is practically it
This
is
okay for this calculation purpose. This
yeah,
example, it is okay.
but in the
Can we really
practical
have such a
no,
situation?
no, because because that has not much impact on the your solution, so that's why we are ignoring. If you are
Okay.
considering very high forcing frequencies and then system, then your transient system like for the say is the a high speed rail where what happens like the if we ignore the transient response, our like the response will not occur because the forcing frequency is higher. So in that case we need to consider the transient response as well. So
Okay.
that kind of system.
Okay, sir.
So in this we need to find out like what is the response for the system. Actually what happens, actually these are options for the next question. Okay, so that will be utilized. This is a derivation kind of thing. Okay, so these options we will use in the next question because I copy paste it here. So we will discuss these options later, but here we can go with the what is the question is stating. So we need to find out the response for the this case where omega is equal to omega n. Okay, so if my omega is not equal to omega n, what is my solution for this? Anyone? Like how I find out the solution for this? Like this equation u dot plus k by m u is equal to p by m sine omega t. So for the particular solution, what are you considering? Like initially I'm considering some u particular up to some constant c time sine omega t, let us suppose. So if I will put it there, here ups, so that would be u, and u double dot would be c minus omega square sine omega t. And if I will put this into that system. So that would be, if these two I put into this equation, so that would be minus a c omega square sine omega t plus k by m into u is c into sine omega t is equal to p by m sine omega t. Sine omega t will be cancelled out, so this will be c omega square plus k by m. I can write it as a omega n square into c is equal to p by m, and if I will take c as a common, so that will become a omega n square minus omega square is p by m. Okay, and if I will take omega as a outside, omega n if I will take outside, so c will become as a p by m into omega n square. So if omega n I will take, so that will become 1 minus omega by omega n square, this one. So if I will put c into this equation, upt, so that my response will become as a p by m omega n square 1 minus omega by omega n square into sine omega t. So this is the my response if my omega is not equal to omega n, because if my omega is equal to omega n, then my response will become infinite, like this equation is not valid. So can anyone tell me now how do I determine for the resonating condition solution? Or I can write it is a small, like in the what is m omega n square is the k into 1 minus 1 minus omega by omega n square into sine omega t. So this is your ut. Okay, so can you tell me now how I determine the response for the resonating omega is equal to omega n? Anyone?
We should know the K value, right? Here.
No, if your omega is equal to omega n, that my system, that the like the
Zero.
denominator will become zero, so that
Yes.
will leads to the infinite, like my solution is not valid for the resonating condition.
Yes. Yes.
So for the resonance, how do I find out the solution? Like resonance, it doesn't meaning like if omega is equal to omega n, my system will suddenly fall or suddenly break. Like it's for the resonating condition, the displacement is very large, like it increases with the time. Okay, like for the 2 second it is, let us say it is a 5 centimeter. For the 3 second it will become 10 centimeter. So that's how it will be increasing, like the for the resonance condition, your response will goes like this, increasing like this. So it is not suddenly like it your resonance omega is equal to omega n, your response is like very high. It is not like that. For the resonance it will go like it is cyclic way, it is increasing. So can you tell me how to determine the solution for the resonating condition? For the finding out the omega is equal to omega n, we consider the solution c sine omega t. So now we can change, like we can consider the another system. Like for this, if we consider, if you will, can you try considering ut as a ct sine omega t or some function ct cos omega t? Can you try with this and find out the solution for the resonating condition? Like instead of considering this function, you can consider this one also. Any doubt in this problem? Are you facing any doubt or you have any confusion? Anyone?
What you did actually? C sin omega t you changed to?
Like we are changing the function, like let us suppose we are considering a function ct cos omega t. So if we like doing that u double dot and then putting these, can we find out
Okay.
the solution using that?
Okay. 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 That is why you are getting that CT sin omega cos omega t.
So
Okay.
that we are using a
Okay.
function, so that,
Okay. Okay.
so that is the one way you can try with. And another way is that, if you remember in your mathematics when we read the derivative or some limits, if my conditions are 1 by infinity, what I use L hospital rule. So can you use the L hospital rule in this equation? You will find out directly the solution. So for the L hospital rule, I need to derivative it both, in the both upper and lower with the derivative with respect to omega by omega n. So let us suppose here my omega by omega n is r. So I can write this equation ut is p. I will make this as also omega by omega n. So omega by omega n multiply omega n into t divided by k into 1 minus omega by omega n square. I can rewrite this as a p sine omega n t into r divided by 1 minus r square. So in the with L hospital rule, what I do, I will derivative with respect to r, and this also I will derivative with respect to r. So if I do the derivative with respect to r, so what is it will become upper side p omega n t cos omega n t r, and this below one become as a minus 2rk. Okay, if I will put again r value as a omega by omega n, which is 1 of, because r is equal to 1, if I will put r value is 1, so my final will become as a p omega n t cos omega n t divided by 2k. So this is my solution. Did you get it? Anyone doubt in this?
Actually, this type of solution already done by a sir in week 3 course, lecture 8. Sir has already done this derivation. While he assumed like you have taken right CT sine omega t.
Yes, in the content lecture you have
Uh,
done this type.
like that, he already derived the same thing for u of t. U of t equal to minus half into p naught by k into omega nt cos omega nt minus sin omega nt. It is there. It's already derived the same thing.
So in the content it is derived with the L hospital rule.
No, no, no.
So this is the new thing now for you.
Okay, okay,
Okay, that's why I did not derive with this formulation, because this is done in the week 3 content. I given you only the, like, you can use this function, so you can directly use this L hospital if you can use the mathematics.
okay.
So this is the simplest way. So any doubt in this? Anyone? Should I move to the next question?
Sir, actually, but
Yes, sir.
we have a numerical answers, right?
Yeah, numerical answers, but something like some of the student is not going through, all the students are not go sometime to these questions. So my intention was just to tell you with the new L hospital rule, to how to find out the solution for this kind of problems. You can go through that. Okay,
Okay,
so this is
okay,
the one derivation only, not all the problems are the derivative, only one problem for the derivative type. To inform like the L hospital rule, using the L hospital rule you can find out the response. Okay, so let's do the numerical question. So in this question we have a steel frame. Okay, shown in the figure, and the steel E value, as we know, 210 gigapascal, and support a rotating machine that a girder level ft, like it supports some machine or whatever it is. So the force transfer at the, like the ft is applied at the top of the frame, which is the 900 sine 5.3 t newton. So assuming 5% critical damping, we need to determine the steady state amplitude of the vibration, like steady state response. And the next is we need to find out the what is the bending stress or the dynamic stress, like bending stress due to the dynamic response. Did you understand the question? Anyone?
Rotating machine exits a horizontal force. Okay, it's a damped system with
Yes.
with a forcing function.
Yes, damped system with the forcing function. Yeah, that's the
So you have all the components K, C, M, and as well as P naught.
everything you have. You need to find out the steady state amplitude of the vibration,
Yeah. That steady state amplitude means that.
particular solution.
Okay.
So in this question, what is the stiffness of the, what would be the stiffness for the column?
2 times 12 by L cube, considering both the columns.
No.
Ah, okay.
Anyone is there? Yeah, that is okay. Two times the
Oh, okay, okay.
considering.
Because of the pinned support, I didn't notice the pinned support because it is
Yes,
fixed support. Okay, this may be half of that actually. 6a by L square,
like
12a by L cube,
two
6a by
two times of the 6ci by L cube.
yeah,
No.
3a by L cube,
Yes, it would be 3i by L cube.
2 times 3a by L cube.
Yes, yes. So if your support is a pin support, your stiffness of the one column is the 3i by L cube. So your K equivalent will become as a 2 times 3ei by L cube. So you have given the E is given to you 210 into 10 raised to power 9. I is also given to you 2880, and L is given to you 4.5. So can you tell me what is the stiffness are you getting?
It is 398.22 into 10 cube.
398.22 watt unit watts, kilonewton or newton meter. So it will be coming out to 398 222.22 newton meter. Is it okay?
Yes, yes, correct.
Okay. And you have given the damping as a 5%. And the mass of the system weight is given to you 70 kilonewton. So you can find out mass into 9.8. Okay. So can you tell me what is the natural frequency of the system? Omega n. What is the omega n? Anyone?
7.47
Unit?
radian
What is the unit of omega n?
radian per second.
Okay. So now we have the omega n. So what is the solution maximum, like the steady state will be given as a RD time the U static. Do you know this thing?
Yes, yes,
So can you find out the U static and the RD? So let us find out the what is the U static is F naught by K, and F naught is given to you like the amplitude 900 Newton, and K is over 39822.22 Newton meter. So what is this U static? Anyone?
2.26 into 10 raised to minus 3.
Okay, so here we are getting 2.26 mm. Is it okay?
yes.
So now find out the RD. What is my RD for the damped system?
1 by root of 1 minus omega by omega n square whole square plus 2 xi omega by omega n whole square.
Is it okay?
Yes,
So now put the value of, like, what is my omega by omega n? So omega is given into the question is the 5.3. Okay. So if you will put omega is 5.3 and omega n is 7.47, what is this ratio? 0.709.
yes,
So now putting this value into this RD, find out what is the value of RD. Put the value of omega by omega n at 0.709, damping is a 5%.
it is coming 1.993.
So okay, it is coming 1.99, so we can write it as a 2.
Yeah,
So what will be my U naught? Would be U static into RD, and U static was a 2.26 into 2, so that would be coming out to 4.52 mm. Okay, now I need to find out the part B, which is the maximum dynamic stress in the column. So in a column, if I have a, like, this is a this one and this is going like this one, so my this one is a U. Okay, and the stiffness is the K is the stiffness. So what will be the force develop at here or at the bottom? That would be the K into U. So K is your 3I by L cube into U. That is your force. Okay, and what will your moment generate at the top, or what is transferring moment? So that will be m time F into L. So it becomes your 3EI by L square into U is your moment. Once you calculate the moment, you can calculate the stress. M over M over Y over I, My over I. Okay. So can you find out what is the forces coming in this system or the stress, where I is given to you, and the at the same time you can directly use the section modulus Z. to find out the stress. So that will become m by z, and z is given to you 67 centimeter cube. Okay, so z is section modulus is given to you 67 centimeter cube. So find out the f or m, 3I by l square into u. Anyone with this? Anyone? Put the 3I by L. L is a 4.5. E, you have the 210 GPA. I is the 2880, and U is the 4.52. So what I'm getting, M maximum bending moment is 4050 Newton meter. Is it okay? And
Yes, correct.
then you calculate the stress M by Z. So that will come out to 4050 67 into 10 raised to power minus 6. Okay, so can you calculate the what is the bending stress? Anyone?
Six 0.44 into 10 raised to 6.
Or what is the unit?
No, say 60.44 Newton per mm square.
Yeah, so in Newton per mm square you can write it as a MPa.
Yeah.
60.45 MPa. Do you know na? Like Newton per mm square I can write it is equal to MPa. Do you know?
Yes, sir.
Yes.
Okay, so my bending stress is the 60.45 MPa. So is it okay? Should I move to the next question?
Yes, sir.
So,
Okay, so now we have the question related to the uh, unbalanced mass. So please go through the question, read this question once. Okay, so read this question. In this question, what we have given, let me read it out. A tail rotor section of the helicopter is shown in the figure. It consists of four blades. Okay, each blade has a mass of 2.3 kg. Okay, each blade mass is 2.3 kg, and an engine box of mass 28.5 kg. Okay, so the mass of the engine box is the 28.5 kg. The center of gravity of the each blade is 170 mm from the rotational axis. The tail section is connected to the main body of the helicopter by an elastic structure. The natural frequency of the tail section is observed as a 135 radian per second. Okay, so during the flight, the rotor operates at 900 rpm. Okay, so what is the vibration amplitude of the tail section if one of the blade fall off during the flight, where the damping is given as a 5%? Did you understand the question? Let
Okay, we get the mass and eccentricity and the frequency of the the blades actually.
Yes,
Rotational,
you have everything.
unbalanced rotational
Yes,
mass,
this
like
is the problem for the unbalanced mass,
each
rotating of the
mass,
unbalanced mass.
then engine box.
Okay, so what we have there given, the mass of the each blade is given 2.3 kg. Okay, and on the other hand, the mass of the toolbox, or we can say mass, is given 28.5 kg. So can you tell me what is the total mass of the system?
Okay. 28 plus 8 plus 31.56.
No, it's not a 31.5. We have the four blades, so we need to consider it the
Okay,
four
but
times.
what I
37.
calculated is, but how I calculated it, no? I did not consider the total mass. I considered this as a blade mass as a, rotating about the pivotal point. So one third of the mass I considered for the blade mass.
No, no, this is not a. We have the each blade mass is given 2.3 kg. Okay, so
Okay.
we need to do first calculation for the before the, like, my blade is like broken out or the fall down. So before the fall down of the like the blade, what is my total mass of the system? Is that 28.5 plus 4 into 2.3 by 3? Is it okay?
37.7.
Yes. So it would be 37.37 kg. Okay, and that it is given to you saying the natural frequency of the tail section is given as omega n is given as a 135 radian per second. So can I find out the stiffness of my system using that? Because the stiffness of the system is not given in the question, so we need to find out what is the stiffness of my system. So can you find out using those like mass and this omega n, find out the stiffness k, which is we can write it as m omega n square.
687.08 into 10 raised to 3.
Okay, so if I write it 37.7 into 135 square, so that will comes out to be 687,082 Newton meter, or I can write it as 687 kilonewton meter. So now I have this these are the initial things I have. So now during the flying, my one blade is, like, let us suppose this one blade is fall down. Okay, so what is my unbalanced mass equation? Is that mu double dot ku plus cu dot is p naught sine omega t, where p naught is m e into r into omega square. Is it okay? Do you know this thing? The amplitude of the m, like the unbalanced during the unbalanced mass, that is given by m into r into omega square.
No, we don't know. Can you please explain?
Like in the week 3 content, when you go the derivation for the unbalanced mass, like for a system, if this is like the a system which is rotating with the unbalanced mass m e, and this r is the, like the, you can say lever arm, or the some, you can say the centroid of this me, and if it's rotate by the omega, so that the the force developed by this rotation, unbalanced rotation, is this one. m into r into omega square. Okay.
Where we can show that P naught in the diagram? Can you please show that P naught?
P naught, it is like that, like if we say, if we, my I have a beam like this, okay, and I have a motor on this, okay. So in this motor, like some sort of something is, let us suppose my mass is like my motor is rotating. So my motor is rotating, then there is something unbalance is happening there. Some unbalanced mass is rotating. So due to this, it and the weight of the motor is m and the rotating mass is the me. Okay. So that is the force produced by this rotating is the p naught, which we given is a me r omega square.
No, no, no. That P naught, can you show? Can you show me in the that beam?
So that beam is like, I can represent beam as a like a stiffness, a damping, a mass, and then my p naught is applied here, like p naught sine omega t. This is, so now my p naught is this.
Okay, okay.
That is okay. Only by amplitude is, because it is a harmonic, because it is unbalancing, so it is creating harmonic type of system. So my this equation, the solution for the mu naught ku plus cu dot is equal to p naught sine omega t. The solution of this equation, only thing you need to replace is p naught with the me r omega square. Only thing is that in the unbalanced mass. And the derivation for this p naught, how we get the p naught is equal to me into r into omega square, that is discussed in the week 3 content already. So I think we don't need to go through here with the derivation. Okay. So some of you have the ask one question in the week 3 content assignment. There is some problem, so you can ask this question on the nptel portal discussion form, so that the TAs will answer you. Otherwise I will ask them to, like, what is the issue, they can resolve this. Okay. So what is my p naught? Can you calculate what is my p naught? Anyone?
What is this R here?
R is the, like the lever arm, like like the distance between the center of the mass to the center of the unbalanced mass, distance between those two.
Can you show in the picture like R? What you are
R
intending
is
to?
the like centroid of this blade, like from this, what is the centroid of this blade, let us suppose this is. So this you can say that R, the radius. Like in the diagram we have given, like the center of the gravity of the each blade is 170 mm. So r is the distance from which anything is rotating, like this, like that is the unbalanced mass me, and this is about this it is rotating. Okay, so that is r.
Okay, it is already defined. 170 is already
Yeah.
defined.
Okay. So m is given to you 2.3, r is given 170, so we need to write it into the SI unit, so it is the 0.170, and omega is given to you 900 rpm. So I can write rpm, to convert into the radian per second square, I need to multiply with the 2 pi by 60. So can you tell me what is the p naught, or keep it here, not to go there. So let we will discuss the what is the solution. So u naught is the p naught by k into rd is my solution. So u naught into p naught is what, me into r into omega square by k, I will write it as a m omega n square into rd. I can replace it with the 1 over, or rd we can find out it is a separate rd. So I can write it as a me into r, or omega by omega n is the some ratio, we can write it divided by m into rd. So for finding out this, first Find out the omega. Now the omega n will change because my one blade is fold down. So for after folding down, what is my omega n? Can you find out? Like initially my mass was 28.5 plus 2.3 into 4, that was the 37.7 kg. But now my one blade is fold down, so my updated mass will be 28.5 plus 2.3 into 3. So what will be this? So that will be 37.7 minus 2.3. So that will come out to
35.4.
35.4. So now using this m dash, can you find out the omega n? As k you have given as a 687,082.5 divided by 35.4. So what is this my omega n?
139.31.
So this is coming out to 139.31 or 34. I think if I will consider the whole something. Okay, 31 radian per second. So now using this, what is my omega by omega n? So omega is given like it is my operating speed at 900 rpm. So what is my omega? 900 rpm time 2 pi by 60. So what will be my omega? Calculate this. Like to convert rpm to radian per second, we need to multiply with the 2 pi by 60. Okay. So 900 into 2 pi by 60 is coming out to be 30 pi, or you can write it as a 94.24 radian per second.
Sir, I have one doubt.
Yes.
We calculate the stiffness
Yes.
there with frequency and the total mass, that mass of blade plus mass of box engine,
Yes.
and that stiffness we have used directly here. Means, but means there is no relation. Means mass is changing.
Yes.
So
Mass
its
is.
effect won't be there.
Yes, stiffness would not change, but actually what happens before the flying, like if I have a system, like a, a system is given to you initially like mass and stiffness, then you have the mass and you know the omega n of the system naturally initially, so you can find out your kn. Okay, now if your mass
Okay.
will change, so it will
Okay.
vibrate at another frequency, like the omega n will not change, the natural frequency will not remain same. Did you got it?
Okay. But stiffness will be same.
Stiffness will be same.
Yes. Yes. Okay, sir. Okay.
So what is my omega by omega n? That is 94.24 divided by 139.31. So that will become out to be 0.676. So now put the value into the u naught, me into r by m into omega by omega n square into rd, 1 minus omega by omega n square plus 2 xi omega by omega n square. Please find out the value of u naught. Now you have everything. Like omega by omega in this one, m is 2.3. Okay, and your mass m will be m dash updated mass, that would be 35.4, which we have calculated, and damping you have given is the 5%. Okay, find out this one, what is the u naught.
It is 5.658 mm.
How much?
5.658.
No, it's wrong. Anyone? So let us put the values one by one. So me is the 2.3, r is the 0.17, m
Hmm.
is 35.4, omega by omega n is the 0.676, 1 upon 1 minus 0.676 square whole square plus 2 into zero point zero 0.05 into 0.676 square. So if I will do that, RD, what will be my RD first? 1 over 1 minus 0.676 square plus 2 into 0.06.676 square. So my RD is coming to be 1.827, and this one is the 2.3 into 0.17 into 0.676, 35.4.
I think a new not you have to correct it as 0.616 square. The first part,
What was the? Okay,
2.3 into 0.17 into 0.676 square.
so that will be square. This
Yeah.
one, okay. So I am getting this one is the 5.047 10 raised to power minus 3, and if I will solve this, I am getting this 9.2215 10 raised to power minus 3 meter. If I will simplify this, this will be 9.22 mm. Is it okay?
Yeah, correct.
So someone got some 6 point something. What was the mistake? Anyone?
Yes, yes, I did a mistake in the calculation.
Okay, no problem. So is there any doubt in this question? Anyone?
What is this 28.5 kg? That
Hmm,
is the
28.5
mass.
mass of the system. Like you can say, like let us suppose Like this is
No,
my
that will be fixed at the center now. I was thinking like it should be fan, or motor at the center of
a
the
motor
pivotal
is
point. So
motor is motor mass is m, that is
yeah,
a
then it should be at the
28.5. Okay, and then there is a, some sort of blades are there. Okay, like my motor is attached with some sort of blades which each blade mass is 2.3 kg kind of thing.
hmm.
So these are in symmetric, but if my one blade is fall down, then it will create the unbalance. If that blade is not fall down, then it is a
No,
balanced mass.
actually, this calculation of mass only I have this one, like, what happens is, mass at the centroid and the mass of the blade.
That is
This will
given
be
to you different, like it is not given you included mass like 28.5 plus blade mass. If
yeah, yeah,
I
correct. But
you
what
are,
I'm thinking is equivalent mass will be different. Actually, it will not be addition of these two. That means the blade and the motor. It will not be 37.7. Actually, this is from practical this one. Uh, because the one mass is concentrated at this pivotal point, and the other masses are, like, away from the this one by distance L or whatever.
yes,
So
but whatever mass that will be transferred to that, like practical point of view, but that mass is attached to that motor, no? So that total mass would be transferred to that.
no, I think we should calculate actually the equivalent mass. This will not be 28.5 is the total mass, and then I think the one third of the mass of the blade should come for each of the blades.
Why one third of that? You are saying some sort of centroid or something.
Yeah, yeah, correct. Based on the centroid, like we solve the problems, like
Achha,
like
okay, you are taking inertial ml square by 3 kind of things. Are you doing that?
yeah, considering the inertia at the center of the pivotal point, like we do for the pendulum, we take root of g by l. We take we consider that length as this one, like mass is considered as one third.
But in that case, what happens? Your mass itself is going through that. Only that mass, that ml square by 3, is going through a some sort of vibration.
Yeah, yeah, correct.
But here your motor is going into the vibration. So
I
your
think generally,
rotation.
they should have given the point, thinking like it is a displacement of a the I think mass, concentrated mass, and along with this mass is not participating in the dynamic this one actually, the motor mass.
Yes, that motor mass is like the unbalanced mass that is fall down, and that the another 2.3, like the three plates, that will be considered in the
Okay, okay,
overall
yeah,
mass.
yeah, okay. You're telling that me is unbalanced mass. Or,
So that's why we are not taking one ME is not taking. That is the 2.3. It is unbalanced mass, and the remaining 28.5 plus three blades mass is considering as a whole vibration.
okay, okay, sir.
So any doubt in this question, or should we move to the next one? Actually, these do you know why? What is the use of these like the unbalanced mass in the practical purpose?
Yeah, we use it in machine foundations design. When we do know, we consider the mass due to unbalanced forces from the machines, especially centrifugal machines or compressors and other thing. We use this.
No, why we use this? Like, look, in the machines we use in the civil engineering. What is the use this?
Pardon?
In the civil engineering, where we
Ah,
use this, like the in the like you are saying in the mechanical system, like it is due to unbalanced mass, there is some vibration. We
okay,
use this normally to generate the vibrations in the system. In the, like if we want to test some structure, like we have a, like some to the dynamic force, like we need to install a uh, some foundation or some, we need to give a frequency or the frequency to the system. So we can give it to produce that frequency with the unbalanced mass to the system. Like you can generate the vibration in the system, any system, with the using these unbalanced mass.
okay.
So testing purpose kind of things.
And what we'll be testing by this providing this unbalanced mass? What we'll be testing? Like
No,
what is the parameter we are trying to get? Uh,
no, the, like we are like we are providing some sort of uh, like what we say. If we are giving any building, we want to give a vibration. So how we give it to that vibration in the actually? So we can provide this mass with the unbalanced mass, which providing different range of frequencies. So we can study the behavior of the building corresponding to these vibration.
Okay.
So that's the thing. So the another question is the same kind of question, but here it is a little bit difficult. Like a 40 kg fan, like this kind of question is given to you in week 3 content quiz also, but that is little bit simplified, that question in the week 3, but this is a little bit tougher. So a 40 kg fan, this is our fan, has rotating unbalanced magnitude of 0.1 kg meter. The fan is mounted on the beam as shown in the figure. The beam has been specially treated to add viscous damping. Okay. So as the speed of the fan is varied, it is noted that maximum steady state amplitude is 20.3 mm. So what is the steady state amplitude when it operates at a 1000 rpm? So did you get the question? Anyone?
Yeah, we can, like a previous example, almost the same this one.
But in this thing, in this question, you have given the maximum amplitude u naught is 20.3 mm of this beam. Okay, so we need to find out the u naught with respect to 1000 rpm. Okay, and for the p naught, which was the m naught e into omega square, so you have given the m naught e is given to you zero point 0.1 into omega square. Okay, and where omega is you given to you this one 1000 rpm. So you can calculate P naught by K into RD. But this system is a viscously damped system. So how do we get the damping for the RD? We need the damping value. So can you tell me how do we get the damping? In this question, main purpose is to find out the like the if you will able to find out the damping, then it is the same as the last question.
Okay, maybe we should find out from the maximum amplitude,
Yes,
omega by omega, and based on that, we have to find out the damping ratio,
yes, that we need to.
equating the maximum steady state amplitude, and maybe we should find out the this damping ratio.
Yes, so how can we do that?
This formula, like yeah, we have the formula like u naught equal to mer by m. This same formula, omega by omega and whole square divided into rd.
Okay, so you are saying U naught is equal to P naught by K into RD,
Yeah.
where P naught is the M naught E into omega square by K is the M omega n square into
Hmm.
RD. Okay,
Yeah, correct.
so now U naught is equal to ME M over M into omega by omega n square RD. So what I can write is this, what is this becomes?
No, rd, from the rd it will have the equation for the damping ratio, no? So, so we have to equate the full equation to u naught. We know the value of u naught as 20.3. So only parameter unknown will be the damping ratio.
So how do we get the, like you are saying, like I will put the RD as a 1 over 1 minus that
Yes,
value?
yes, 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 yes. There only the damping ratio is there. So, but I don't
So
know if omega n is known or omega n we can find out. Yes, because we have the EI value and other this one. So we can find out omega for the beam.
yes,
Yes.
you can do that. You can try with that. I have one another way.
Okay.
So we can write U naught is equal to ME M over M.
Hmm.
This I can write it as a RA.
Hmm.
Is it okay?
Ah, okay.
So
Correct. Yes, yes,
so
yes.
RA,
Yes,
Okay.
yes.
so RA
Okay.
becomes U naught time M over ME into, sorry, this I have to write it as a,
Ah, correct. Yes.
okay. So this value U naught is given to you 20.3 mm into 10 raised to power minus 3. M mass is given to you 40 kg of this motor. Me into R given to you 0.0, 0.1. Okay. So what is this Ra value? Can you find out? That will be coming out to be 8.12.
Yes, 8.12.
So for the maximum, what is the value of maximum Ra, Rd, and Rv? If you go through the lectures, for the Rd, what is my maximum value? 1 over 2 xi,
Root of 1 minus xi square.
1 minus xi square. And same value for Ra. Okay.
Yes, yes, yes.
And Rv is given to you 1 over 2 xi. Okay. So I know the Ra, so I can put it equivalent to Ra, so that will be 1 over 2 xi 1 minus
Sir,
xi.
here I have a doubt actually. The
Yes.
RD and RA will be different. I think it inverse of each other
No, no,
actually.
no, no, that will
It
be
will not be
same.
same.
It will be
In
same.
the maximum condition only it is possible.
RD and
RT
RA, you mean to say are same?
Same for the maximum.
for maximum condition only.
Yes.
Okay.
So using this, you can find out the damping.
And maximum condition is defined as how do you define actually?
Maximum at the
Maximum means
resonating condition, can you say?
okay, at the resonating condition.
Yes.
There we have only maximum amplitude. They are given already in the problem. Maximum amplitude is given. Accordingly, we are finding RA as a maximum.
Yes.
Yes.
So now using this, you can find out what is the damping value. Now do some, you can directly find it with the calculator, or you can do the, make it the polynomial equation, doing a square in the both the sides, then you can find it. Give a try.
0.061694. 6%, 0.061694.
Yes, nearly. I'm also getting this. Xi is the 0.00. Sorry,
06
617. I'm getting this one. Okay.
617. Yeah, 61694.
So now you have the damping, and that one thing was you are telling that you are getting through the RD. So in this case also you can replace this RD. Okay, that you are telling now. So that RD also you can replace here also that thing. So that will become all the same equation. 1 over 2 xi 1 minus xi square. Okay, or in this case
Hmm.
because this is corresponding to the resonancing condition, so that omega by omega n will become 1. Okay, because we don't know the omega initially, so we are finding out the maximum response is corresponding to resonating condition, so that will become to the 1. Okay, so that will become your same equation. Did you get it?
Mm, that's all. Only 2 zeta by 1 minus z square. Okay.
Because RD and RA is same.
Okay.
Okay, and if you will
Hmm.
go to this, because that RD and RA these value and RB these values are corresponding to the resonating conditions, where we have the like the forcing frequency is given as, if you will go through this, for the RD the forcing frequency was the omega is equal to omega and 1 minus 2 xi square, and for the RD, for RV omega is equal to omega n, and for RA that was the omega n divided by 1 minus 2 xi square.
Ah, this is where I got confused actually. That's why I
Okay,
told will it be
so
same or
these
different?
are like different, but when you do the calculation like putting these value into RA, RV, RD, then you will go to the RD and RA will be same. If you do the mathematical calculation derivation in the putting the value of RD, RA, RV, you will get the RD and RA as the same, and RV is the 1 over 2 side. Okay, any doubt?
Here, this RD omega and 1 minus 2 psi square. It's root square root. It's for
It's a like
resonance
resonating,
condition.
yeah, resonating conditions.
Resonating condition. Okay.
Yes, yes. Okay,
Okay.
so using this damping ratio, now finding out the steady state amplitude with respect to omega is the 1000 rpm. So 1000 rpm, I can write it as a, I can convert it into the radian per second. So that will be 1000 into 2 pi by 60. So how much I will get it? It will comes out to be 106.229 radian per second. Okay. So now you can get u naught is the m e into r, or m into omega by omega n square into rd. Okay, so now you can put the value, find out the rd. So you have the omega, now we need to find out also the, we don't have the omega n. So for finding out the omega n we need to find out the k. So k for the beam, what will be the k?
PL cube by 3I.
3i by l cube. Okay,
3I by L cube.
so find out 3 into e is given to you 200 into 10 raised to power 9. I is given to you 1.3 into 10 raised to power 6, 10 raised to power minus 6, not the 6. Okay, and L is given to you 1 meter. Okay, 1.2 meter. So what will be your K? Anyone with the K?
451.38
Okay, so you are getting 451,388.8
Newton meter. Newton
Newton per meter. Okay, and you have the mass is the 40 kg. So you can find out the omega n. 451388.8 by 40. If you will go through this, it is coming out to be 106.229 radian per second. And that omega was, I have written wrong. So that was the one, not the 106. That was the 104.71. Okay, this one. So now you have the omega n, RD, ME into R, M, everything you have. So now find out the RD. 1 minus 104.71 divided by 106.229 square plus 2 into 0.0617 into 104.71 divided by 106.229 square. So can you find out RD? Anyone with the RD?
Actually, I'm getting 8.
Yeah, I also getting 8. So do the further calculation. So I am getting RD as a 8.01. Okay. So now you get the U naught was the this one ME into R over M into omega by omega n square into RD. So that will become ME into R, what is zero point 0.1. Okay, into M is what, 40 kg, omega invert 106.229, and omega was 104.71 square. So if you do the calculation.
19.459 mm.
Into 8.01, so you will get the around
19 point,
19.44 mm. Is it okay?
yes.
So anyone has any doubt in this question? In this question, main thing was to calculate the damping only. So in the your Qs, I think the damping is given to you directly, so that you have the damping, then you can calculate the U naught easily. So any doubt? Anyone? Anyone?
But here the if it is this ratio of successive cycles, how to solve that? This was not clear to me actually. In the suppose if it is
This ratio of successive cycle you need to, then you need not to calculate the, you have the U naught and you have the sine omega t, like the, this is the steady like combined response. You need to look into this for the damped system, how you can calculate, like in the, for whatever system you are solving, p naught into rd into sine omega t, whatever it is your response with corresponding to damping. So you can do it with the multiply with the sine omega t, and you will get the your response, and then you can find out their logarithmic decrement.
logarithm 2 pi, it will become 2 pi psi by square root of 1 minus psi squared. No?
What is
2
2
pi psi by square root of 1 minus psi square. That logarithmic decrement
2 pi psi or 1 minus psi square, the square?
by square root of 1 minus psi square.
How you are telling this, like I don't get it.
No, the logarithmic decrement formula I forgot actually.
Logarithmic decrement is the simple, like the
Hmm.
ui over ui plus 1 is equal to 2 pi n into psi. Yes, this is your logarithmic decrement. This is your logarithmic decrement.
2 pi.
2 pi n is the number of cycle.
Okay, okay, yeah, okay, okay.
2 pi
2 pi
n
psi.
psi.
For one cycle, okay. One cycle, if you here you are considered only one cycle, ui by ui plus 1, you are considered one cycle, 2 pi psi only.
Yes.
So, okay.
So now we have the this
Why
is,
we have to multiply by number of cycles? Okay. Then
yeah,
for so many cycles, 2 pi
yes,
psi. Okay, one cycle only. Our problem is suppose if you are given successive cycles, then we have to consider this only,
yeah.
2 pi psi.
This is only for the maximum amplitude. We are not going to the logarithmic decrement. To find out that uh, that number of cycle, you need to, you need to plot this, like first of all, like with
Hmm.
the may you not multiply with the sine omega t is your final response. So you need to plot it with that what are response you are getting, and then you can find out what is your decrement and what is it. For one cycle, two cycle, you can directly get 2 pi n psi.
You are talking about the assignment 3 question, right?
Yeah,
Yes,
yeah, correct,
yes,
correct.
yes.
Exactly.
That
Yes,
that
this is what I
xi,
got.
that xi, we can find the xi from this that equation, right?
Yeah, xi you can find from this equation, but we don't have the ui and ui plus 1. Like we should have.
That is what I don't have that UI plus. That's what I was coming to actually because
So
I didn't understand because we don't have the displacement. This one,
yeah, so if you don't have
but
the
anyway, we have
displacement,
the ratio. Suppose 2.5 is to 1. If the ratio is there, then this is there actually. So we
so
can find out from there the xi value.
so where is the ratio ui over ui plus 1? Do you have that ratio? Then you can
Yeah,
find
yeah,
out.
yes, yes.
In
Yeah,
the
yeah.
there is a,
2.5.
like, is there any question like that?
Yes, yes, yes.
The
Yes.
14th
So
question.
initial
14th.
UI is 2.5 and
Yes,
UI plus
yes,
1 is 2.
yeah. That is something like the 1 second and the 2.5 centimeter, something like that.
No, seconds. Both are seconds. Successive cycles is ratio is
Okay,
2.5 is to
that
1.
that's ratio is given to you. Okay, okay.
Yeah, yeah. So then ln 2.5 equal to 2 pi psi.
Yeah, then you can find out. So in the chat box, someone has some doubt or something. Was what was that? So he has a one query. Assignment 3 is radian per minute. Mentioned in question 4. It is a RPM. Yes, that is a radian per minute. That is the same, I think. Or I will ask them to clarify what is the issue. So let us go to the last problem. A machine is supported on a four-wheel spring of which damping can be neglected. Okay, so we have a machine which is support on some sort of a spring, so the damping is zero. So the natural frequency of the vertical vibration of the machine spring is the 200 cycle per minute. Okay, so it is given to you by RPM. So the omega n given you to 200 RPM. The machine generate a vertical force Pt, P naught sine omega t. The amplitude of the resulting steady state amplitude displacement R U naught is the 5 mm for 20 rpm. So that force is applying at a P naught sine omega t. So due to that, they are getting the a different rpm omega and omega, and they have the U naught with the damping zero. So omega n given as a 200 rpm. For omega is 20 rpm, the U naught is given to you with 5 mm. For 180 rpm, it is given to you 26.47 mm. For 600 rpm, it is given to you 0.63 mm for zero damping. This is the case they have given, so we don't need to do anything. So now what they have done, we need to find out the amplitude if we replace these spring with the rubber isolator. Rubber means the rubber has some damping, so with the same stiffness. Okay, so now we have provided with damping of 0.25 or 25%. So with corresponding to that damping, we need to find out what is our U naught. Okay, and then we need to comment like which system is effective at which, like which rpm my system like isolators are effective to reduce the uh, response. Did you get the question?
Yes, good.
Okay, if you get the question, so now we have given the omega n, so we will give go to the one by one. Okay, so first let us go. Omega n given as the 200 rpm, and omega is given as the 20 rpm, and u naught is given as a 5 mm. So if for the undamped system xi is equal to 0, what is my response? U naught is equal to ust into rd. So I can write ust into 1 over 1 minus omega by omega n square. This is the response for the undamped system. Okay, so from here I need to find out, I know what is my omega, what is my omega n. So and u naught is given to me 5 mm. So 5 into ust into 1 over 1 minus omega is the 20 and omega is the 200 is this. Okay, so now I need to find out what is my ust. So can you find out the ust?
4.95.
So that you are getting UST as a 4.95 mm. Now in this system, if I will add the damping 0.25 or 25%, now I need to get out the U naught into RD. So UST is 4.95 as you calculated, and RD now becomes as a 1 minus omega by omega n square plus 2 xi omega by omega n square. Okay, so now calculate the RD for this. So that RD would be 1 over 1 minus 20 over 200 square plus 2 into 0.25 into 20 over 200 square. So what is RD? Anyone with the answer?
1.088008.
Let us check. So that is coming out to be 1.008, like nearly 1. So my U naught will become for this system is the 4.95 into 1. So that will be 4 point. If I will use this whole 0.88, so that will become 4.99. Okay. Now do the part B. Same procedure we need to follow. Part B, you have given in the part B, U naught is given to you 26.67 mm, and forcing frequency you have given 180 rpm. Okay, so find out the first UST. So U naught is equal to UST into RD. So that would be 26.67 into UST into RD will be 1 minus 180 by 200 square. Okay, so what is my UST from there?
Five point zero six seven three.
5.0673. 26.67. Okay, so from here I am getting my UST is 5.0673. So now find out the U naught with the damping 0.25%, 25%. Anyone with the answer?
10.373.
So that is coming out to be 10.3 nearly. Okay. Now part C, if you do, you have u naught is 0.630 and your omega is 600 rpm. So that would be, first calculate the rd. So that would be 1 over 1 minus omega by omega n square. So that would be 1 over 1 minus 600 by 200.
There u naught is 0.63.
Yes,
Is it correct?
yes, yes. If you go through the question, we have given the 0.63 mm. Okay.
Okay, that means okay. Omega n is increasing, right?
Yes,
Okay,
if you are I will give you the explanation
okay.
why it is lesser. So if you will calculate this RD, so that will be comes out to be 0.125. So if you will calculate the U naught is given to you. So U naught into UST into RD. So that U naught is the 0.63. UST into RD is 0.125. So your UST would be nearly 5.04 mm. Okay. So now you can calculate the U naught with the 5.04 into 1 over 1 minus omega by omega n square plus 2 xi omega by omega n. So can you tell me what is your U naught?
0.619.
Okay, so that will be your 0.619 U naught, 0.619 mm. Okay, so let's summarize the results. So with omega n 200, with omega is over 20, 180 and 600. With that, we have u naught with damping is equal to 0. We have u naught as a 5 mm, 26.47 mm and 0.63 mm. Okay, and with damping u naught 25%, we are getting the response 4.99, 10.3 and 0.619 mm. Okay, so we can compare how much the rubber, yeah, or the isolator decrease the response. So in the first one, decrement is around 0.14%, in this around 61%, and in this around 1.75%. So that you have the one question like why it is a 0.73. So look at the omega by omega n ratio. So when I go to the response RD response curve, so it look like this one. Okay, so when omega by omega n is 1, like here we can see like 180 by 200 it is like left side, so that's why we are getting 26.47 higher result. When it is going to the omega by omega and 3, nearly this 3, so that's why we are getting 0.63. Yeah, that's why it is a 0.63. Okay.
That means if you more than natural frequency, uh, we couldn't find the displacement much. Can we
Yeah,
say?
yes, in the response, if you go to the this response curve, rd versus the omega by omega n, and if we have done the one example in the second example in this question also, as we you increase the omega by omega n, your response will start decreasing, but after omega by omega n greater than 1.
Okay, okay.
If you go to the curve, either you can plot those curves also by taking any of the equation. If you see this curve, in this curve you can see, like after the 1, like in the left side, like before 1, my response is increasing with omega by omega n is higher than like increasing, but
Okay,
in the right side, when my omega by omega n is greater than 1, my response start decreasing. Okay.
okay, okay.
So in this question we can see, like when my system is near to the maximum, like omega by omega n, like not the 1, but it is around zero point 0.9. Yeah, for zero point 0.9 my reduction in the uh, damping or response is 61%. So if my omega is equal to omega n, my damping control the my response. Do you agree with that?
What?
If my omega is in the resonating condition, damping control the my response. Do you
Yes, yes,
agree that? So in
yes.
this case we can see also, like when my omega and omega n are nearly equal, not the 1, it is zero point 0.9, like in this range. So where my damping is how much effective, you can see the decrement in the response is 61%. Okay, but at the same time, if you will apply the damping in the other another cases where the your omega by omega 1 is in the lesser than, or it is like not in the near the resonating period, like let us suppose it is like in this period or in this period, where the damping is not much effective. Okay.
Yeah, understood, understood.
So that is the one thing. So like in the part b, where omega by omega n is nearly zero point 0.9, my response is decreasing significantly, because in this question the main purpose is to show that in the resonate near the resonating conditions, my damping play a bigger role in the resonating conditions. Okay, so due to related to damping, we can some any question, some sort of the type question. That was the one example that we didn't discuss those options. So that was like that, those, where is that example? Yes, in this example. So forget the statement of this. Yes, so forget the statement of this. I am saying that a velocity amplitude rv is given to you. So if I in the resonating condition, let us write a question. If I have a resonating condition, omega is equal to omega n. Okay, so what will happen to my velocity response factor? Velocity response factor rv, if I doubled the double or the half, if I double the damping, like from xi 1 to 2 xi 1, I will do that. So what effect rv will, what is will with my rv, the ratio of this, like in the one case my xi 1 is xi, in the another case xi 2 is 2 xi. So what is the ratio of rv1 to rv2? These are the four options you have. So in the resonating condition we have discussed, for rv was 1 over 2 xi. Do you know this?
Yes.
So if so my rv1 is this, and then rv2 will become 1 over 4 xi. Okay, so what is my ratio?
2.
So rv1,
Okay.
so rv1 by rv2 is the 2, so the rv2 is become, so I can write rv2 is equal to 2 into rv1. Okay, so that my D option is correct. No, that is point 0.5. So that is point 0.5. So any doubt in this question?
No.
So if anyone has any doubt in the all the four problems, you can ask me here.
Actually, I have a doubt in assignment 3.
Yes.
That was, I think, second question, assignment 3, second question. Do we have any problem? I thought like it is the wrong options, I think.
In the assignment 3, let me check what is the assignment 3. Which question was that?
Second question options. I'm asking about second question options.
So what would be the frequency of vibration after a time that is 10 times the natural period of that question?
Yes, yes, that question.
So
Actually, in the first question we have options. We got the answer, but in the second question the same options there, but answer is not coming. That's why I'm asking.
so in this options are same. So
Should it be 13 actually?
damping ratio is given to you 2. So
Yeah, point 0.2, 20%, point 0.2.
okay, so
So we should get 13, 13 this one, like, megawatt wave frequency.
wait.
Okay.
No, options are okay. You will get the answer if you will do the calculations. Those options are okay. So I can't I will not tell you the answer because uh,
Okay,
so, but the
okay,
options are correct if you will do the uh, uh, correction, because like I can give a hint, like the solution of the equation,
okay.
like I can give you the, like in the, if you will go to the
Hmm.
solution of the damped system, what is the solution? Ut is equal to e raised to power minus xi omega t
whatever.
into a cos omega dt plus b sin omega dt plus some particular solution. I don't know what is that.
Yes, yes, yes. From that only we will get the natural
So
frequency.
you have the omega d, okay, and you know the relation between the omega d and omega n, then you can calculate. Are you doing the same?
Yes, okay. I think they are asking frequency of vibration means double omega d.
They are
Can-
asking you the like the okay, omega n is in the first question. So what is the frequency of the vibration after the 10 time of the natural frequency? Okay, so that is a different. Okay, I was looking at the first one. So
First question is okay. We got the frequency, but after 10 times of the
yeah, 10 time of the natural period, if you will calculate the
uh,
logarithmic decrement, if you will
yeah,
do that,
so much decrement will be there.
wait, omega,
I'm getting 1 radian per second means 10 times decrement.
actually the options are okay. Once I will ask, you can put a question on the ask discussion form. There is actually,
Okay.
let me once check this, is it okay or something else.
I, I
So
have a question that uh, they, they are asked after 10 times of the natural period of system, they are asking frequency of vibration means what? Omega,
like at what frequency your system will vibrate, you need to find out that.
omega, omega n.
You can, like, you have the equation, you can plot that equation, you will get it. The options are correct, there is no problem with the options.
Okay, okay. Then the ninth question, can go for a ninth question.
Okay, what is the issue in the ninth question?
I thought maybe it is a basic question, but I don't know how. While writing this equation of motion,
Yes,
I have a small doubt that we have a spring force and a damping force,
yes,
and we have a sinusoidal force, nothing but.
yes, yes,
But we have a mass, right? With a hinge, it rotates at
yes, yeah, yes,
at
yes,
hinge O, right?
yes,
While writing this, I'm writing like I theta double naught
yes,
plus damping plus damping moment and stiffness force moment,
yes, yes,
which is equal to our force, right? F naught sin omega t.
yes,
While calculating I,
yes,
I have a ml square by 3 for rigid this bar.
yes.
Then how do we can take this mass? This 4m.
Okay, for the 4 mass, you can calculate like what is my displacement at that L by 2 into theta
L by 2 into theta.
is the
Yes.
displacement. So that would
Yes.
be the 4m L by 2 theta double dot.
Okay. Right.
Okay, so that
Ah,
way you can go through that.
thank you. Thank you. Uh, 1 minute. Can you give a hint for the second question I didn't get till now? Just
Second question, I told you like you can plot it, you will get it. I can't tell you answer, but the options are okay.
plot means
You have the
for
given the equations you have, and you can plot this equation with take any coefficient of a b c d. you can take any random coefficients and then plot it, and then you will find out what at what frequency it is.
Okay.
So that's where you can find out. I can't tell you the answer of the any of the questions.
Okay, okay, no problem. I don't want any answer. Just I'm thinking how it is going. Okay, no problem.
Yes,
I will
if you
discuss.
are facing
Sorry,
any other doubt, you can like write on the discussion form as well as, so I will be there to happy to give you the answers. Yes, someone
sir.
has.
Suppose if the
Yes, yes.
initial and next displacement is not given, uh, how to calculate the damping ratio if two successive this one is not given?
Okay, if two successive is not given, how do you get the ratio?
Damping ratio, yes,
So
yes,
is
yes.
there any question in where the in that question you are talking itself, the second question?
No, no, nine. Question number 9 in the assignment.
You have
10th.
already said na that logarithmic decrement method. Ln ui by ui plus one.
So
It
in
is
the what you are saying, question number 10.
No, but if UI plus one not plus one is not given, how do I calculate the logarithmic decrement? Because just simply based on C, M, and K, and we cannot,
So which
or
question
in
you
the
are
applied
talking?
question,
Can you tell me?
number 10, number 10.
So in the number 10, there is no need to applying the logarithmic decrement, I think.
No, but there is see there one way is to always damping ratio. We always calculate based on the this no successive displacement only. If I don't know the
No,
displacement,
no. If you
uh,
don't know the displacement, you have given C. You can find out C critical. So that is the C over
uh,
C critical. Simple.
uh,
So you can find out C
okay,
critical two m omega,
okay, okay, correct,
and
correct. Yes,
C
yes,
you
yes.
have.
Okay,
So you can. There is no need to calculate
okay,
using.
okay. No need for any from the basic parameter itself. We can find out
Yeah,
the
yeah.
damping ratio. No need for the
Yes,
yeah the successive displacements. Okay, this
yes.
is correct actually.
So this way you can, like, these are simple
Yeah, yeah,
simple
correct.
question if you will think. Otherwise you have any doubt, you can go through the lectures,
No,
like.
this is actually it looks simple now because after you told me now I understood actually, but I was getting confused because we read so many things, simple things we suddenly forget. Actually, it was
Yes.
very helpful. Like this, what you told is very simple answer, but it was not striking. However much I try, it was not striking. Now it's clear actually.
Okay, if these kind of doubt I can solve you, no problem.
Yeah, yeah,
Like
correct.
how to,
Concept based. These are only
yeah,
concept based. Like
only this
how to
concept based.
calculate without the
Yes,
how to calculate without the the consecutive reduction. How to
yes,
calculate. So this
yes,
I got actually. Okay.
yes. So
And somewhere this amplitude. They are saying steady state amplitude and then some whole amplitude or some other absolute amplitude. What is the difference? Determine the absolute amplitude means what it is steady state amplitude or total. Total. No, this is total amplitude.
I think when it's come to the force vibration, they are always talking about the steady state amplitude, and
Huh.
the
But
absolute
here,
mean.
but problem is, yeah, here the problem is, I just know omega t time, we don't know. So how to calculate? There's some 14th, 13th question for a frequency harmonic force.
Actually,
Yeah, harmonic force.
actually, absolute amplitude. Absolute means what? It should not be any sign convention.
Okay, that is the meaning. It's a
That,
steady state only we have to take.
yeah, absolute meaning that only. If you
Yeah, yeah, correct,
absolute
correct.
things meaning
See, they
that.
have written, yeah, yeah, determine the absolute amplitude of the forced response. No, but forced response only. They are not saying
Yeah,
exactly
they
the
are saying
due to
everything.
forcing function. So here it means steady state amplitude.
Yeah, only steady state you need to go through that.
Yeah, because we cannot solve that. Otherwise, it becomes an equation and continuous this one. So we cannot anyway solve it like. It has to be for the maximum P case only, particular case only. Yes.
Yes.
Okay.
So, okay, if any suggestion about this session, if you are facing any issues, you can ask me here, or you can ask any discussion forum if you are having doubts.
Okay, I'm okay with this session.
Okay,
Thank
if,
you.
It was extremely useful, sir. Very
okay,
useful actually.
okay.
May I know when will be available this session? Just for a first half an hour, I didn't there.
That will be available after 1 or 2 hour. Like I will upload on the YouTube, and then you will get it. No
This
problem.
is the third session, right?
Yes, yes.
Thank you very much.
Okay. So if you have done, you can like leave the meeting.
Yes, sir. Thank
Yes,
you.
sir.
Thanks a lot.
Bye.
Okay.
Thank you so much.